So we have Alex on the IoT show, and we did some cool stuff. The first thing was to twin stuff from the ISS, and then Alex here will show us how he is visualizing the ISS in his living room and play around with real-time data. That's today on the IoT show. Hi everyone, you're watching the IoT show. I'm Olivier, your host, and today I'm joined by Alex to discuss Azure Digital Twins and an interesting use case that Alex has put together. Alex, how are you today?
Hey, not bad. Not bad.
Awesome. So Alex, today you're here to tell us how you implemented a modelization and tracking of the International Space Station leveraging Azure services. That's the title be below here. It's pretty fancy. I love that. Little teaser. There's going to be some HoloLens involved as well. I won't say more for now, right? It's just to keep people's attention so that they stay here. So before we get started, Alex, who are you? What are you doing at Microsoft? What is your background?
Yeah, so I'm a software developer by trade. So spent maybe 15 years doing software development, worked in various small companies in industry based around Aberdeen and Scotland. Worked at a small company called the Marsden Group, and we happened to be lucky enough to get acquired by Microsoft. And we do. So what we did was innovation projects around IoT and AI and Azure. So generally finding cool problems and then trying to solve them using IoT and Azure products, and continue to do that as part of Microsoft. So hopefully, making the world a better place, one problem at a time.
Nice, the dream job. Because I think when you say cool projects, that's an understatement. When I look at the type of projects that you can share and some you cannot. So that's pretty cool. How did you came up to this project we're going to see today? And that, by the way, everyone will be able to access to on GitHub. So how do you come up with that?
So it all goes back to last Christmas. So on Christmas Day last year, I think the James Webb Space Telescope launched, and maybe sounds like a boring Christmas. I sat and watched the launch of the James Webb Space Telescope at Christmas, and I saw it and I thought, what is the ultimate edge device? A space probe, a telescope. I wonder if you can get telemetry from it. So I went and hunted for some telemetry. Unfortunately, I didn't find any for the James Webb Space Telescope, but I stumbled across this public telemetry feed for the ISS. Okay. So I thought, well, let's have a go and twin that. Let's pull some data from the ISS and see if we can push it into a digital twin. And that's it all sort of snowballed from there, really.
Nice. You just coined a new verb. You twinned that? That's what you did, right?
Yeah, just twinned that.
We're going to use that. I love it. I just twinned that thing. Okay.
Yeah, just twinned that thing. I think that's an awesome phrase.
That's pretty cool. What is your job? I twin stuff,
I twin stuff, yeah. Digital twin magician.
So you started there. That's the background. You wanted to twin that. So basically, you wanted to model that data, because I can imagine there's like a lot of sensors on the ISS, lots of data that is coming through. You wanted to make sense of it, right?
Yeah. So I think wanted to make sense of it. One of the problems was I knew there was a telemetry stream, right, but I didn't know what data there was on it. So how do you twin something that you don't understand or you don't know? You just know there's stuff. So I ended up putting some Azure services together, like an Azure Function app to look at an event hub, and then try and infer DTDL models and twins and maintain them automatically from the stream.
Okay. And we'll look at that in your architecture diagram. We're going to look at in a second in terms of the overall project, but you also have a notion of historical data. So digital twins not just allows you to model data set, but also allows you to go back in history when that data is timestamped. When it's historical data, you want to go back into to do analytics and whatnot. So, and it's paired with ADX, Azure Data Explorer. We have another IoT show episode describing that integration. So show me a bit, that architecture diagram. How does it work? Because at the end of the day, it's pretty simple. That's my perspective, at least.
Yeah, definitely. So basically, we've got two data sources, the ISS, obviously, and something called Celesttrack. But basically, this Celesttrack data source is something that enables us to position near-Earth objects, their orbits around the Earth, and you can calculate their orbits. There's a couple of Azure app services that sit and run. One of them takes data from this light streamer service and onboards to an IoT hub. The other one takes TLE, which is two-line data files on the ISS's actual telemetry, orbit telemetry, and will infer its lat and long, and they onboard that to an IoT hub. Then off of that IoT hub, we have the thing that really helped with this project, or helped us get started, was we wrote an Azure function app that takes the JSON messages, the payloads in the JSON messages, and enables you to automatically generate DTDL models based on those JSON message payloads, and then generate twins, and then patch them based on. You don't need to put config in, but you can configure it so that it looks for certain tokens in the message payload and generates twins based on what's in the message payload. Otherwise, you end up with a model in effect per message, but you can have a model. You can minimize the number of models that are generated by using those configurations. Then from that, once you've got the data in ADT, we historize that data. So we've got the Azure data history turned on. And one thing to note is actually, if you think of IoT edge devices, a key thing is that they don't always, when the data hits your IoT hub or your ADT instance, the timestamp, you don't want to track the time it was ingested. You actually want to track the source time. So as part of the ingestion, we actually patch the source time because it's a property on the ISS messages. And then that means we can go and see the source time in the ADX historization piece and query the actual time these values changed, because you can see that in the feeds, right? The data buffers a lot, or can buffer.
Yeah. Well, in between the sensors usually and the cloud service, there's that thing called the internet. But in the case of the ISS, is even further away, right? Because or bigger. And we had another episode recently with an MVP. Chris Tacky was talking about sending stuff or IoT devices to space and all the problems, that you were facing. Like the communication is not constant or permanent. It might be a bit more with the ISS, but not always, right? So you might lose connection. You might want data to be bufferized and so on. So you want to track, as you were saying, when the data was produced at the source, so that this is the timestamp that is relevant when you're looking at the data for sure. Okay.
Yeah, definitely.
Well, tell me more, and then we'll get into Data Explorer and we'll look at that data in ADT.
Yeah. So so once the data got into ADT, we wanted to visualize it. So we used Grafana, hosted in Azure, to build some graphs, allow us to trend data, and actually allowed us to explore and find out what data we actually had, because we didn't necessarily know. And then also we built, it was only the sensor twins that were provisioned. So we had to build a twin around the sensors that we got and make sense of them, give them context. So structural context using the ADT graph to enable us to then further explore the data and really understand the correlations between sensor X and sensor Y and why they were changing. And what I can do is I can go in and I can show you the twins that we built, and I can show you the different stages of building those twins.
Okay.
So when we first ingested the data, this is what we ended up with. You can see, I think there's maybe around about 100 twins. I'll zoom in a tad. So you've got these twins for a sensor. and you can see you've got all of this information about a twin that's streamed from the ISS. We don't necessarily know what, I'm not really an expert on the ISS. I mean, I read, as part of this project, I read a book, but this is the kind of data we ended up with.
Interestingly, so what you just said is very interesting, because you have a raw feed of data, right? Data comes structured in a way that you don't know because you're not in the business of space stuff, right? And you were, though, able to create a model, like some culture reading, whatever, but you were able to create a model with digital twins and the DTDL language, which is JSON LD based. So you need some JSON skill, I guess, and you model everything. So that's interesting, because that means that you don't have to be a data scientist, you don't have to be a space or a rocket scientist, I would say, but you still are able to create a model of that data that is coming from that space station.
Yeah. I mean, it was literally, if you think of a twin as a thing, you're just creating JSON representations of things using DTDL. So, I mean, once the automatic things were there, we could then go and generate other things. So initially, what we started off with was this idea of, well, there's a property on twins that seems to be called discipline. So we went and found out what that meant, or I went and found out what that means. And it turns out discipline means, if you've ever seen like films about the moon landings and stuff in mission control, each of the desks with a small sign above it, that's a discipline or a call sign. So we thought, well, that means we can group these by something as a starter.
Mm-hmm.
So we tried to group them. So if we look at this sensor here, US Lab 43, if I double click on this, we should see the discipline that this sensor was we categorized it as. So
got it. So you twinned the disciplines this time, and you established relationships between the sensors that were tagged with that discipline with that new twin that you created there.
Yeah, exactly. And so what that meant was we then had these groupings that we were able to navigate through. Yeah, so as we can see here that we've double clicked on that sensor, and what's happened is we can now see that for that sensor's actually grouped in the discipline ADCO.
Mm-hmm.
And we can actually see all of the other sensors that we happen to group under there. So you can see these sensors Z1010 or something. But then also we can see the next stage that we went on was we then thought, well, let's actually go and understand the physical structure of the twin and create of the ISS, and create a twin of the physical structure. So we can actually see that sensor is connected to US Lab and Node 3. So we've had this whole twin of the ISS. Now, we've got this idea of grouping twins from two different dimensions. So, ADT allows you to group your twins or model the relationships between twins in more than one dimension. So we've got it by a notional thing called discipline, but we've also modeled them by what they're attached to physically.
Mm-hmm. Yeah, and physically you can have element sensors or part of a discipline in different places on the station, so different locations, basically.
Yeah, exactly. And then when you think of putting them on different locations, that means that you can actually, people tend to understand the physical rather than the notional, oh, this is sensor X, Y, and Z. If you tell them, well, this is the US lab, here's the sensors that are attached to it, it makes way more sense.
Yeah, makes sense. And we'll see that towards the end. Once again, second part of the teaser about visualizing in 3D, that data and all that information you're gathering here. Okay, so here you're visualizing. So you basically created models, created the relationships. You have now a big twin of the station with data from all the sensors. So you talked about historizations, right? You talked about leveraging ADX as well, so you could go back into history and investigate what happened in the past.
Yeah, exactly. So I'll show you a couple of queries that we did. So what we did was still didn't necessarily, we grouped these sensors by discipline, still didn't necessarily know what these sensors were, but we were able to go and then use the ADX historization piece. So for example, I've got a query here to query the sensor called US Lab 33 and bring back its value over a period of time. So we were able to run these queries, and then based on the queries, you can actually see the shape of the data, which began to help make more sense. So we were able to see trends in data, or see, for example, with the altitude of the ISS, go and figure out what's the min and max value that you have. And that means that we can start to visualize. If you think of a dial with a min and max, you can start to place the current value of whether it's high or low, for example.
Yep. Is it based on the fact that the rotation of the station around Earth is not a circle, right? It's more elliptic, and so the altitude will vary, right?
Yeah, so different points in the orbit, it's going to be higher up. Its apoapsis is going to is further away from the Earth than its periapsis. So the altitude is going to vary. It's not necessarily a perfect circle.
Okay.
Yeah, so I mean, with that historization, it meant that suddenly we've got something we can query. We're not just querying ADT for a point. For now, we can go and say, well, what was the value in the past? What has the average value been? Stuff like that, which means we can use visualization tools and stuff on top of that.
Nice. Visualization now, so you can not just visualize the real time, the actual or latest known value, but you can go back and rewind basically, and rewind your metaverse, rewind your twin here. I love that notion. Okay, well, like, tell us and show us a bit about how you did the visualization in Grafana, because I think that's an interesting piece of software out there. There are solutions with the Microsoft, but they're like third-party solutions, more than welcome. And Grafana is a great tool. How easy was it to integrate that data from the twin into Grafana, or from Digital Explorer, actually, to be more Azure Data Explorer, to be more precise?
Yeah, so I mean, it was relatively easy. I mean, so Grafana is pretty cool insofar as you can host it in Docker. So we were able to host this Grafana instance so we created a Grafana instance by hosting a Docker image on an Azure web app, which meant that brought all of the security and stuff that Azure App Services do. So we've got, HTTPS out of the box with minimal configuration. This is integrated with AAD with just environment variables. But then once you get past the initial setup, you want to build dashboards, right? So what were we doing? Well, we used the Azure Data Explorer data source for Grafana, which enabled us to query ADT. So, I mean, if I take us to the mission control panels, which is the first panel we started with, this was the panel that enabled us to helped us to explore the data that was history, right?
Yep.
What I'll do is I'll show you the queries that we built behind here. You can see there's drop downs here that have the disciplines that we spoke about, and then for each discipline there's sensors. It's a cascading drop down list. This is actually driven from ADT using the ADX ADT query plugin.
Got it. So behind the drop down, when you do a filter here in Grafana, it will invoke a different query or change the query so that it grabs the data from ADT/ADX and brings that into Grafana based on that filtering here.
Exactly. So in here with this, we've just got a simple ADT query that's running to go and get disciplines.
Yep.
And then the second query is taking the currently selected value here and actually running an ADT match query to find the sensors that sit underneath. So we're not just querying by a tabular join, we're actually doing a query based on the structure of the graph itself.
Yep.
Rather than just saying, oh, well, give me all of the things that are joined to Spartan. It's a little bit more nuanced than that. But what that then enables us to do, so we can go and discover stuff about our data, right? So if we go here to Topo, which is the navigational data for the ISS, we can actually go and look at I think this is US Lab 33, so we can see the last 3 hours. So you can do all the stuff you could do in ADX, Azure Data Explorer. You can see there's various panels, but behind them there's ADX query. So what I can do is I'll show you an ADX query. I'm actually an admin on this. One of the things, so with AAD, what you sometimes find is, even though you're set up as a Grafana admin, by default it'll log you in as a viewer. So you have to quickly go back in and say, right, I want to go and administer this, so you don't accidentally make changes, which is maybe a good thing. So if I just go into the orgs here and go into users and find myself, I can change myself to the admin and then refresh.
Which usually when you're a viewer and change yourself to admin, this is not something anyone can do, right? It's just because you haven't.
No, it's just because I am. It's because I am an admin. It's
just saying.
Yeah, it's not something that happens automatically. So if we go back to the mission,
and I was looking at the video feed you had on that first dashboard. Just want to say, I think we're unlucky that it's day of the time where it's night, because we do see something there, but it's kind of dark.
Yeah, so it's probably
middle of the
time
ocean.
Of day that's caused. Yeah, look, it's probably the time of day. You can see there's a bit of light now. We can check back on this in a minute. We might actually see the sunrise.
Let's go back to the flow. Sort of an interruption on that one.
So if I go back into here now, I can edit these queries. So what I'll quickly just show you the variables so that drive the drop down. So we've got our selected panel. There's nothing too fancy in there apart from the ADT plugin. But then I'll show you the sensor one, which has the ADT query plugin plus ADX data history. So we're taking our ADT endpoint and then we're running this digital twins match query. So we're just saying go and select the description of the description of the sensor, run this match thing. So go and get components which have the relationship has member, and then joined by the selected panel, which is the discipline we've selected, and make sure you're bringing back a sensor and evaluate that query, and then it basically just projects it as a drop down, and you can even see the preview of what of what's going on. So there's a nice little editing user experience there as well.
Brilliant. So that's a quick question before we go to the next question I have for you. How long did it take for you to, make sense of the data, create the models in digital twins, and then create visualization in Grafana? In a nutshell, how long would you say it took you?
For the ISS, I mean, maybe 3 days, if that. I mean, to get the data into the twin, it was there in less than a morning. But then when building the Grafana dashboards and hooking all together, maybe 3 days, a day of polishing at the end.
Yeah, still 3 days is nothing when you think about
right?
The amount of information. So we're talking a lot about IoT and services allowing to not just visualize the data, but also to integrate into business apps or workflows. So here I would like for you to show me something, that you showed me when we were preparing for that IoT show, which is very interesting and fascinating, which is not just visualizing data, but creating rules to trigger alerts that will then trigger workflows. And you have an anecdote here, which I think is pretty fun to share with us. So let's talk about alerting and triggering workflows from your application here.
Yeah, so one of the things that happened during when we were building this was we created this social media panel just for fun, just so we could say, oh, look what's going on the ISS, you can go and view it. So one of the things that came up was that there was actually going to be a resupply mission whilst we were building the system, like the day before we finished building it. So me and a couple of the people who were playing around with this decided, well, shall we go and see if there's any data we can have a look at, see if we can generate an alert, a proximity alert, because we found this sensor called Rus G005. And what we found on it, so if I quickly switch back to the mission control panels, what we found was that sensor itself that sensor itself was described as distance from the service module.
Mm-hmm.
And from reading the book that I bought, we found that that was where things dock. So we're like, well, okay, so constantly reads a certain value. We don't know if it changes, but maybe we could trigger something if it changes. So what we did was we decided to, I don't know what happened there. Hold on. So we decided to go and try and build an alert based on the history of that sensor. So we look in here. I'll just show you what we did. I'll refresh that. Yeah, so if we look in here, I'll show you what we did. Basically, you can create these alerts in Grafana. You can hook them into contact points like as Teams or Teams channels. And we basically created an alert which runs this ADX query, which is the history of our sensor. So Rus G005. Just go and look at the history of that based on timestamp. And then you can set up some simple conditions. So we just set up a condition that said, if the latest value of that is less than 6,000, then check every minute, check the latest value every minute. And if it's less than 6,000 for 10 minutes, send an alert to Teams to the ISS proximity channel, which is one we created during our demo there.
Nice. And you just demonstrated because something happened then, right? So going back in history now, you can look at the sensor data and see the capsule that was actually getting closer to the station and docked.
Yeah. So we set up that alert and then forgot about it, went to bed. Next morning, came in and the Teams channel had an alert in it saying that something had docked. And that was the realization we had, where we maybe thought, because up until that point, we weren't sure if the data was simulated, right? Maybe it was public and just this is an approximation of what's happening. And then something happened in the real world and it appeared in our twin and something happened. So
nice.
It was awesome to wake up to that. It was nice.
Nice, and you did indeed validate that the real data was coming in, and here you're looking at we're looking at your main dashboard. We have the live feed, well, we don't. It's not clear what you're looking under, but the location of the station right now that you see on the map to the right definitely matches what we're looking from the live video feed, and you can just follow along with the station here. It's pretty fun. I love that.
Awesome.
So, Alex. We teased people a couple times. Let's switch to the other way of visualizing. When we talk about digital twins, people do, and we talk about metaverse and so on. People do see, or have in mind 3D and augmented reality and so on. So you took your project a bit further, and you brought the ISS into your room, right? So tell us a bit about that and show us.
Yeah, I mean, so what we did was there's a learning path on Azure Digital Twins, and it's about integrating with HoloLens. Mm-hmm. And it's a nice little sample project that has wind turbines and a simulator that makes these wind turbines spin. So what we thought would be cool, because we actually had real data, is let's just go and let's see if we can just change it from wind turbines and have the Earth and the ISS.
Okay.
And we were able to do that.
And once again,
show you if you'd like.
You guys are not like 3D gamers, designers, or whatnot, right? So this is once again use of technology that's available to not a random, but developers out there for them to create applications. They're very rich, and you'll see how rich in a second. But that's something that is not in the realm of impossible for the common developer out there.
Yeah, exactly. It's literally, I mean, I know how to do a little bit of Unity, but I've been through that learning path and built the HoloLens app for wind turbines and digital twins. And I mean, so if you go onto the Azure Learning portal, it's there and it's easy to use. So there's nothing to say that you can't take that app, go through the learning path, and then repurpose it for something that you're twinning or you would like to twin.
Yep. So let's see what you've done.
Let's see. So we'll see if I can join it because it's shut down again.
So that people, while you're setting things up, so basically you're using the remote assist function of the HoloLens so that I can visualize what you're seeing in Teams on my side, and I will display that so that people can have the same view that you have. That's the one thing with HoloLens, is that you have this experience of your own to share it. It's not trivial so that people realize what's going on, but remote assist, we figured, was a great way to do that. Cool. So I'm now in Teams. I can see you. I can see what you're seeing. So I see the space station with the globe under, and we are in your room. I can see the window out there. It's pretty cool. I love it. So tell me more.
Yeah. So this is the HoloLens app. We took an open source model that NASA have online of the ISS. It's actually got some. It's made up of a lot of component parts. We then used the Signal R component to stream updates from specific twins, which was our sensors of the ISS, and link them to specific pieces of the ISS. Now you'll see here, and if I walk over, it's probably easier to see. You'll see here that there's a gimbal here. So the position of these, of all of the solar panels actually changes based on the actual position they are being reported as by the sensors on the ISS twin. Now, other things, so the radiators are also the same. The other thing that we've got going on as well is that the ISS actually moves around the Earth, so its position updates in near real time. And when we're talking about latencies, I mean, the latencies that we've detected, we get a latency, the shortest time that data takes to come is probably around about 6 seconds, but generally it can, on average, it's about 11. But then, the ISS is buffering all the time, so we're also getting data that can be up to 19 hours old. But because of the source timestamp work that we've done, we end up with we're getting data that's ordered, albeit after the fact.
This is awesome. Cool, Alex. I think, and once again, like you have now a model you can visualize in augmented reality. You can bring up the data from the Twin and Data Explorer and display it. You can also do things such as, if there's a problem somewhere, you can turn things into different colors, right? So basically, you would see a solar panel all red when there's a problem. Yes. Well, basically, like in movies, right?
Yeah, exactly. So, like for instance, when we were doing this, we actually had some rules set up on the 3D model that colored these modules, right? So based on the cabin pressure, and we actually saw a drop in cabin pressure across all of the pressurized modules. And when we spoke to some people who knew, and it wasn't a massive drop, but it was a continuous drop and then a repressurization. And they said, yeah, sometimes you get slight leaks on the ISS, but you just repressurize. So it was awesome to see that kind of thing, and see you can do that based on that hysterized data and the data from the twins. You can do that with any twin, so it doesn't have to be something as outlandish as the International Space Station. It could be a machine in a factory, right?
Yeah, this is great, Alex. I will ask you to come back to Earth, and we'll wrap this one up. This is cool. Well, actually, I want to bring up that other stream real quick here, where we're seeing now the live feed. The station moved on and is now in the daylight, which is pretty cool. It moved pretty fast, actually. How long does it take for the space station to go around the globe?
I think it's around about 90 minutes.
Right. So basically,
several times a day.
Wow, that's pretty cool. Okay, Alex. Well, thanks a lot for that trip to space and for showing us that really good project that demonstrate how simple it can be and powerful it can be to model data, to visualize and inspect your data in time, thanks to ADT and ADX. and visualize that in 3D. That was. I hope you're going to come back with more projects like that. I love that.
Yeah, I hope so. Yeah, I love doing it.
And because your team is more than cool, you guys are sharing your projects when you can on GitHub. So if you want to learn more about what you just saw and eventually reproduce, because the feed of data is out there, right? If you don't have a HoloLens, you can use a tablet. You can use something that allows you to run these Unity apps and have augmented reality. But all the information will be on that GitHub repo. That is a community project, right?
Yeah, it's a community project, and so you'll be able to contribute to it and fork it, use it to do your own stuff or whatever you want, really.
I just look forward to see what people come up with. Alex, thanks a lot for your time today. Thanks everyone for tuning in, and see you soon on the IoT show. Bye.
Cheers, bye.